Hello students, in today's class, I'm going to explain how to solve numerical on moment of force. We can expect three types of questions from force lesson. Okay, so question number 1. The moment of force of 10 Newton about a fixed point O is 5 Newton meter. Calculate the distance of the point O from the line of action of force. So let me draw a diagram to explain this problem. So consider this body which is pivoted at point O and the force is applied at this point. The force is given as 10 Newton. And after applying the force, there will be a turning effect produced in this body. So this turning effect is called moment of force, which is given as 5 Newton meter. Now the question is to find the perpendicular distance between the fixed point O and the point or the line of action of force. So this distance we need to find. The formula which we need to use to find the perpendicular distance is moment of force is equal to the product of force and perpendicular distance. So in this question, the moment of force is given as 5 Newton meter and force is 10 Newton and perpendicular distance we need to find. So just cross multiply and simplify it. So 5 Newton meter divided by 10 Newton is equal to perpendicular distance. So on simplifying, we'll get the perpendicular distance as 0.5 meters, which is the required answer. You can expect this question for 1 or 2 marks. Okay, so let's go to the next question. So question number 2. This question we can expect for 3 to 4 marks. A uniform meter rule balances horizontally on a knife edge placed at the distance 58 centimeter mark when a weight of 20 gf suspended from one end. Draw a diagram of the arrangement and what is the weight of the rule. So this question has two parts. For drawing a diagram, you will get a mark, and for getting the weight of the rule, you will get the next mark. So here the diagram is not given, we need to draw. Let's see how to draw the diagram of this arrangement. So consider this as a meter scale or meter rule. Okay, let me mark these three levels 0, 50, and 100. So this scale is balanced at 58 centimeter mark. So this is the fulcrum or pivot point. When a weight of 20 GF is suspended from one end. So which end? That is the question. See, if the weight is not suspended, this scale tilts in left hand direction, isn't it? To balance it or to bring it to a horizontal position, we need to apply a weight on the right hand side. So the weight 20 GF is suspended on the right hand side. And the question is to find the weight of the rule. So weight of the rule acts at the center of gravity of the rule, that is at 50 centimeters. So which we need to find. Now find the perpendicular distance between the force and the fulcrum. So this distance is 42 centimeters and this distance is 8 centimeters. Okay. So moment of force due to the force 20 GF and force W. As you can see, one is a clockwise movement and other one is anti-clockwise movement. Now, what is the principle of movement says? By using the principle of moments, we can say that total clockwise movements is equal to total anti-clockwise movements. So this one is a clockwise movement, the moment caused by the force 20 GF. So the formula of moment is force into perpendicular distance. So force is 20 GF and the perpendicular distance is 42 centimeter is equal to anti-clockwise moment. Force is W, which is not known. We need to find it. And the distance is 8 centimeter. Just simplify this. 20 into 42 divided by 8, that is equal to the weight. So 4 2 times, 4 5 times, 5 1 times, 5 21 times. So 21 into 5. So we'll get 105 is equal to W. So therefore, we can write weight of the meter rule is 105 GF. So this is the method to solve a problem of this kind. Okay. So first we need to draw the diagram of the arrangement, mark clockwise and anti-clockwise movements, find the perpendicular distance between the force and the fulcrum, use the principle of moment, substitute the values, simplify and get the answer. That's it. Now the last one more type of problem is remaining. So let me solve that problem. When a boy weighing 20 kgf sits at one end of a 4-meter long seesaw, it gets depressed at this end. How can it be brought to the horizontal position by a man weighing 40 gf? So this question is based on a seesaw. So let me draw a diagram of this arrangement. So consider this as a seesaw. And the length of the seesaw is given in the question, that is 4 meters. The length of the seesaw is 4 meters. The fulcrum of the seesaw is at the center. Let this be the fulcrum. Now, read the question. When a boy weighing 20 kgf sits at one end of 4 meter long seesaw. So at one end, okay, a boy is sitting weighing 20 kgf, sits at one end, let it be this end, okay. It get depressed at this end, so obviously. But the question is, how can it be brought to the horizontal position by a man weighing 40 kgf? So that man has to sit on the opposite side, isn't it? But where, we don't know. So the distance we need to find. The boy is sitting here and a man sits here, okay. So distance between the fulcrum and the boy is 2 meters. And the distance between a man and the fulcrum we need to find, okay. Show the direction of movement, clockwise and anti-clockwise. Use the principle of moment. So what it says, total clockwise moments is equal to total anti-clockwise moments. So total clockwise moments. So it is the product of force and the distance, isn't it? So here the force is 40 kgf. So this side, the side in which man is sitting, produces clockwise moment. That is 40 kgf, and distance is not given, we need to find. So let it be d. On the other side, force is 20 kgf, and distance is 2 meters. So simplify this, we'll get d is equal to 20 into 2 divided by 40, that is 40 divided by 40. So distance is 1 meter, okay. So we can say that man has to sit at a distance of 1 meter from the fulcrum. So that is the answer. You can expect these 3 types of questions. One for 2 marks, the first one, and the second and third one you can expect for 3 to 4 marks. So thank you. See you in the next video.